Hey class, thanks for looking up this video. Just want to give you a short tutorial for our 511 Investigating Quadratic Functions handout. This is how we interact with a table, a graph, and then to describe our parabola. Our central question is, how is a quadratic function different from a linear function? Well, a quadratic function, as you'll see, forms a U-shaped parabola, where a linear function forms a straight line. So how do we get a parabola? Well, we've got this function x squared minus 2x minus 3. What makes this quadratic is the fact that we have the x squared. All right, so how do we fill out this table? I've got a few values, but how do I find these values? What do? I plug in the x value. So I'm going to give you an example here. We plug in -2 wherever x is. We put -2. And I use my order of operations. I do parentheses first, then exponents, multiplication, division, addition, subtraction. So -2 squared and -2 times -2 is 4. -2 times -2, again, 4. And because a negative times a negative is a positive, I put plus 4. And lastly, minus 3. So we have 4 plus 4 is 8. Minus 3 gives us 5. All right, now how do we get from the table to the graph? We just plot our points using a smooth U-shaped curve. All right, so my first point, -2, 5, it doesn't fit on here. So I go to my next point, -1, 0, -1, 0. I don't go up or down, I stay right there. 0, -3, 1, -4, 2, -3, and here we go. I connect it with a smooth U shape. Now if I stop right there, this looks incomplete. I can continue this line. In fact, I actually know that it passes through this point. You'll notice in your table, -3 matches with -3. 0 would match down here with the point 3, 0. That's because parabolas are symmetrical, meaning what happens on one side also happens on the other side. All right, so let's talk about describing our parabola. The direction of opening, there's two options. It's either up like a cup or it's down like a frown. And if you look at this, it looks more like a cup, a smiley face. So direction of opening here is up. To find the vertex is a pretty important point. It's the turnaround point. You'll notice on the table it has no match on the table. It's the highest or the lowest point. In this case, our vertex is right here, this point. And that point is also right here because it has no match. Now you're saying -2, 5 doesn't have a match, but you'll notice -3 and -3 do, 0 and 0 do, so 5 would match with the point 4, 5. Hey, this one's sandwiched in the middle, so 1, -4 is our vertex. All right, to find the axis of symmetry, the axis of symmetry is the line right down the middle. It splits our parabola into two equal parts, left side and right side. Okay, so our axis of symmetry is the line x equals 1. All right, that comes from this part right here. Our minimum or maximum value is just the highest or the lowest y value. And so in our parabola here, the lowest y value is -4. And that comes from the y part of your vertex. And last but not least, we've got our intercepts. Our x-intercept is where it crosses the x-axis. Our parabola crosses the x-axis at 2 points, here and here. My first point is -1, 0. Second point, 3, 0. And my y-intercept, where does the graph cross the y-axis? Right here at 0 and -3. And that's it. Table, parabola, and a description.